Okay guys, got my hands on the 2022 Special Exam 1. Um, just a reminder for those of you who haven't done a Special Exam, or obviously haven't done a Special Exam before unless you're repeating. The people who write these exams, generally they can't do it in the time allotted, and a lot, sorry teachers, but a lot of teachers couldn't possibly do it in the time that's allotted. So don't be too stressed if you feel like you stuffed this exam up, because it is a bloody hard exam. I'm assuming already, only because methods are so easy. Okay, so, we don't have the obligatory dynamics questions. Does this mean they haven't put it in? Okay, consider this equation, z squared plus 6iz minus 25. It's complex. Express pz in that form, so complete the square. So let's say z squared plus 6iz plus halve that and square it. We get 9i squared, which is minus 9. I've got to add 9 on to balance it, and I've got minus 25. So we can say z plus 3i squared minus 16. Hence or otherwise, find the solutions to this equation. So z plus 3i squared is equal to 16. Z is equal to negative 3i plus or minus root 16, which is 4. Okay, hopefully all 3 marks for the rest of this thing is the same. Okay, this looks like it's harder. What are we going to have to do? Separate this apart. So we're going to get 1 on root 4. What's wrong with my handwriting? 1 on root 4 minus y squared dy is equal to negative x dx. That's going to be sine inverse of y on 2. Remember, it's a square root of that value. Is negative x squared on 2 plus c. We know that y of 2 is 0, so we get sine inverse of 0 is equal to negative 4 on 2 plus c. So we know that c is 2. So sine inverse of y on 2, negative x squared on 2 plus 2. So y equals 2 sine, let's put this over a common denominator, 4 minus x squared on 2. Not too bad too so far. This is early for a probability question. The time taken for a coffee bean to dispense a coffee cup varies normally with a mean of 10 seconds, standard deviation 1.5. Find the probability that more than 34 seconds is needed to dispense 4 cups. So the probability of 4 cups being greater than 34 is the same as 1 cup being greater than 17 on 2. We could say 8.5 because I'm likely to stuff that up. We know the standard deviation of 4 cups is 1.5 times the square root of the sample size, which is 4. So we're going to get 3 on 4. This is the same as the probability that z is greater than 8.5 minus 10 on 3 on 4. 4 times negative 1.5 is negative 6. So the probability that z is greater than negative 6 on 3, which is negative 2. So we know that is 0.023. So 1 minus that is 0.98 to 2 decimal places. The machine is to be serviced. After its service expected, the mean time taken to dispense a cup of coffee will be reduced. The standard deviation will remain the same. Find a 95% confidence interval for 25 cups, and that's 9. Okay, it doesn't say an integer. So it's 9 minus 1.96, which is 49 on 25, times our standard deviation, which is 3 on 2 times root 25, which is 5. So 3 on 10. 9 plus 49 on 25 times 3 on 10. Okay, so we get 9 minus 147 on 250. 9 plus 147 on 250. 147 on 250. If we times it by 4, we get 1,000. 147 times 4, 8 plus 2, 5, 88. 9 minus 0.588. 9 plus 0.588. Okay, what do we want it to one decimal place? So 9 minus 0.6, 8.4. 9 plus 0.6, 9.6. To one decimal place. Bit of thinking to start off with. Oh, more thinking. This is going to be partial fractions. 3x squared plus 4x plus 12 on x squared plus 4. A on x plus bx plus c, because it's irreducible, on x squared plus 4. Okay, from this we get 3x squared plus 4x plus 12. Ax squared plus 4 plus x bx plus c. Alright, so we're going to get ax squared bx squared, so a plus b x squared plus cx plus 4a. So we know 4a is equal to 12, the constant, so a is equal to 3. We know c must be equal to 4, the coefficient of x, and a plus b has to equal 3. We know that a is 3, so b is 0. Okay, so this is the same as a is 3 on x, bx plus c, 0x plus 4 on x squared, well, 4 plus x squared I'm going to write it as, because then it will be a tan question. Now, we know the first bit is 3 natural log of mod x, plus, here we need a 2 on top, because it's the square root of that. So 2 tan inverse of x on 2 plus c. Pretty easy once you get that partial fractions part out of the way. Okay, a body of mass 10 kilos. Doesn't make you label it. Okay, initially it slows down a smooth inclined plane, so there's no force. The plane is inclined at an angle of theta, tan theta is up. So we know this is 10g. If we know tan of theta is opposite over adjacent, that's going to be root 10. So we know this is 10g sine of theta, and we know that sine of theta is going to be 1 on root 10, which is root 10 on 10. Okay, so we've got that force going down the plane, which is root 10g. That's equal to our mass times our acceleration. So our acceleration must be root 10 on 10g. We know it's initially at rest, u is 0. The speed of the body after it's been in motion for 2 seconds. So v is what we want to find. T is 2, a is root 10 on 10g. We know v squared equals u squared, no v, u squared plus 2as. No. What do I want to find? What bloody formulas is there? V squared equals u squared. I need a formula sheet. Just had a a mental blank. U plus AT. V equals U plus AT. U V equals U 0 plus AT. So root 10 on 2 times root 10 on 10g, which is going to give us root 10 on 5g. So the speed is root 10 on 5g. Does that make sense? Because we wanted to find the speed. Okay, our body's been in motion for 2 seconds. A constant braking force is applied parallel to the plane, so the body has a constant velocity. So our acceleration must be 0. So our force down the plane must be equal to our force up the plane. So our resistance force must equal this 10g sine theta, which is just root 10g. Because it's got to be in equilibrium. That force and that force have to be equal. You could say root 10g down minus the resistance force is equal to our mass times our acceleration, which is 0. And you can see you get r is equal to root 10g. Oh, 6 marks, Jesus. Oh, I was like, where's the rest of the question? Find the cosine of the acute angle between those vectors. So first, let's find the magnitude of A. 4, 9, 13, 49. Square root is 7. 1, 4, 4 is 9. Square rooted is 3. We know cos of theta is the dot product of these. So 2 minus 6 is minus 4 plus 12 is 8 on 7 times 3, which is 21. Okay, OPQ is a semicircle with a radius of A with that equation. P, X, Y is a point on that. So has this A got anything to do with that A? Well, then that's not a vector, so. Okay, express the vectors OP. So to get from there to there. So that's just going to be X plus Y, XI plus YJ. So we know OP must be XI plus root A squared minus X minus A squared J. Okay, Q to P, we know that's the same as from there to there. Q to P, so negative 2A and then plus X, so X minus 2AI plus root A squared minus X minus A squared J. Okay, using this vector scalar dot product, determine whether OP is perpendicular. Okay, so they have to be perpendicular because this is a semicircle. So that has to be a right angle. So that's what we should be aiming for. So it should equal 0. So OP, otherwise we stuff this up. OP dot QP Okay, if we dot them together, we get x minus 2a plus, if we multiply them together, we get a squared minus x minus a squared. We get x squared minus 2ax plus a squared minus x squared minus 2ax. You might ask, why am I doing this? I'm just making sure that I don't stuff anything up. X squared minus x squared minus 2ax plus 2ax. A squared minus a squared, which is 0. Therefore, OP is perpendicular to QP as OP dot QP equals 0. Okay, number 7. Okay, Kepler's equation, that find the gradient of the curve and put it in that form. So we know that's going to be 0. We've got to use the product rule. So that, the derivative of that times that, we get cos x plus y, plus we've got to get the derivative of that. If I've got cos x plus y, I'm going to put this down here actually. I'm going to say here cos x plus y. If I say d dx of cos of x plus y, we can say u is x plus y, therefore y is equal to cos of u. U dash is going to be 1 plus dy dx when I derive that. Dy du is going to be negative sine of u. So that is the derivative, when I multiply them together, is the derivative of that, and I've got to multiply it by x. So I'm going to get minus x sine u, x plus y, times, I'm going to say dy dx plus 1, just because it's easier, is equal to 0. Let's bring the cos x plus y to the other side and divide it by x sine x plus y. So we get dy dx plus 1 is equal to, I'm not going to make that negative because when I divide it by a negative, they're going to cancel. So cos x plus y over x sine x plus y. And then we can bring that 1 to the other side. So we say dy dx is equal to that minus 1. Now we know dy dx is therefore cos of x plus y minus x sine of x plus y over x sine of x plus y. So dy dx is, now they're all x plus y's, that plus that is going to be 8 pi on 24, which is pi on 3. So we've got cos of pi on 3. So we'll say dy dx, given x is pi on x is pi on 24, y is 7 pi on 24. Okay, so we get cos of pi on 3, which we know is a half, minus pi on 24 times root 3 on 2 over pi on 24 times root 3 on 2. We know the denominator there is going to be 48. So on top, we get root 3 pi minus, that's going to be 24, multiplied by, flip that sucker, so we get root 3 pi and 48 on top. Okay, we can cancel the 48s. we need to multiply this by root 3 on root 3. We're going to get it in the right form. It looks like it. We would get 24 root 3 minus 3 pi on 3 pi. If we divide 3 by 3, we get 8 root 3 minus pi on pi. That was a bit of a doozy, but not too bad. Still 3 questions left. Okay, a body moves in a straight line so that when its displacement from a fixed origin x meters is its z acceleration, the body accelerates from rest in its velocity. V is equal to negative 2 meters a second when it passes through the origin. So we know when x equals 0, v is negative 2. This is our acceleration, but we're talking about velocity in x. So we can say v dv dx is equal to that, or a half v squared is equal to the integral of negative 4x dx. Therefore, v squared is equal to 2. Now what's here? Times negative 2x plus c. So negative 4x plus c. We know when x equals 0, v is equal to negative 2. So let's put that into there. C is equal to 4. So we can say v squared is equal to 4 minus 4x. Therefore, v is equal to plus or minus 4 minus 4x. When x equals 0, v equals negative root 2, therefore v must equal negative 4 minus 4x. Or we can take out the 2, 1 minus. Is that supposed to be x squared? Squared, 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 squared. Find v in terms of x for this interval. Not too bad for 4 marks. Okay, I have no idea how long this exam is taking me. Okay, given that f dash of x is equal to that, find f of x. Okay, so we've got to use a substitution when we derive sine 2x. So if we let u equal sine 2x, du dx is 2 cos 2x, which is the numerator. So we can say cos 2x is a half du dx. We can say that f of x is a half cos 2x, we can replace with a half du dx. And we know that's gone, so we've got 1 on u to the power of 3, which is u to the negative 3. We can say that's du. If we antidiff this, we add 1 to the power and divide by the new power, so we get negative 1/4 u to the negative 2, which I'm going to say is 1 on 4 u squared, which we know is sine squared 2x. Negative 1 on 4 sine squared 2x plus c. So negative 1 on 4 sine squared 2x plus c. When x equals pi on 8, y is 3 on 4. So we get 3 on 4 is equal to negative 1 on... Okay, what's sine of pi on 4 is root 2 on 2 squared is a half, 2 on 4. Yep. So that's 4 times a half plus c. So we know c is 3 on 4 plus 1/2, which is 5 on 4. So we can say f of x is negative 1 on 4 sine squared 2x plus 5 on 4. Okay, we're nearly there. That wasn't too bad. Okay, sketch the graph of sec 4x. So if I said cos 4x equals 0, we know that 4x would equal pi on 2, until next time 3 pi on 2. So we get pi on 8 is our first asymptote. And next one would be 3 pi on 8, but we only want to graph it to pi on 4, so we don't need to worry about that. The other one's going to be here. Going to have to speed up, I need to go to the loo. Okay, it hasn't been dilated, so it's going through 1. It's going to look something like this, and something like this. And we know that's the point 0, 1. That's x is pi on 8. X is negative pi on 8. That's going to be an endpoint. So it's going to look something like that. Pi on 4, negative 1. That's going to be the same. Inclusive, negative pi on 4, negative 1. Okay, there's no horizontal. Label any asymptotes, their equations, label any turning points and endpoints. Okay, so that's everything. Last question. Okay, for the graph of that, it's rotated about the x-axis to form a solid of revolution. So our function, f of x, is that. So our volume is going to be the square of that. So volume is pi sec squared 4x dx between negative pi on 24 and pi on 48. Seems like it's going to be ugly. Okay, we know if we derive tan 4x, we get sec squared 4x, we get 4 sec squared 4x. So here, if we anti-diff this, we're going to get pi on 4 tan of 4x between pi on 48 and negative pi on 24. So we get pi on 4 tan of pi on 12 minus tan of negative pi on 6. Okay, what the hell? Tan of pi on 12. What do we know? Tan. We know tan of pi on 6 is equal to 2 tan of pi on 12, 1 minus tan of pi on 12. If I multiply, what's tan of pi on 6? 1, 2, root 3. So that's 1 on root 3. 1 on root 3 is equal to 2 tan of pi on 12. Is it easier to just use a compound angle formula? I think it will be. one of two things. Pi on 12 is basically 15 degrees. So 45 minus 30. So tan of pi on 4 minus pi on 6, which is tan of pi on 4, 1 minus 1 on, no, it's plus, no, minus 1 on root 3 over 1 plus 1 on root 3. So we've got root 3 minus 1 on root 3 divided by times root 3 on 1 plus root 3. They cancel. Root 3 minus 1 and root 3 plus 1 times that by root 3 minus 1 on root 3 minus 1. On the numerator, we get 3 minus 2 root 3 plus 1 over 2. So we get 2 minus root 3. So we get pi on 4, 2 minus root 3. What's tan of negative pi on 6 in the last quadrant? So it's negative, and that's 1 on root 3. So plus 1 on root 3. All right, so we got pi on 4. Fire up, can't be bothered anymore. 2 root 3 minus 3 plus 1 on root 3. Okay. That we can just say is minus 2. So we get pi root 3 minus 1 on 2 root 3. Multiply it by root 3 over root 3. We get, we're going to get a 6 on the bottom, and then on top we're going to get 3 minus root 3 pi. I guess we could check pi, just to make sure I didn't stuff anything up. The integral from negative pi on 24 to pi 48. Yes, I know you can't do this during the stack. Sec. In the exam, sorry. Sec 4, I'm only checking anyway, squared dx. It's a decimal. Simplify. 3 minus root 3 on 6 pi, is that what I got? 3 minus root 3 on 6 pi. Okay, done. Hopefully I got everything right and didn't stuff anything up. Be interesting to see if I did, but I need to go to the toilet. I'm going to wet myself. I'll upload this soon. Bye.